So my name is Kate McClure, and for those who don't know me, I'm the Coastal Climate Specialist for the Maryland Sea Grant Extension Program. And I'm based over on the Eastern Shore at the Y Research and Education Center. But in my role, I serve coastal communities throughout the state with helping residents and decision makers understand and prepare for the effects of climate change. And coastal flooding is a big part of that work and is what we will be talking about today. But before we dive into the real content, there are just a couple Zoom housekeeping items I'd like to mention. You should be able to have the ability to both communicate via chat and also a Q&A function. The chat you are more than welcome to use for sharing any comments or additional resources or thoughts or anything you'd like to share with other participants. However, if you have any specific questions that you're looking for an answer from me, I would appreciate if you could put those in the Q&A. That'll just help me make sure that I don't miss anything, nothing gets lost in the chat. Sometimes things can fall through the cracks there. And I will also be stopping for questions about halfway through and also at the end. And if you would like to ask a question verbally, you can raise your virtual hand and then I can unmute you if you would prefer to ask a question that way. I should just note though that this webinar is being recorded, so if you choose to do that, your question will be recorded. So with that, today we are talking all about coastal flooding. So during the next hour, we'll discuss some of the causes of coastal flooding in Maryland, including tides, rainfall, storm surge, sea level rise, and how this flooding might change in the future. And then towards the end of the presentation, we'll also be going through some of the available mapping tools for understanding your flood risk. And just as a reminder, there is another webinar next week, which is all about what we can actually do about flooding. So understanding your flood risk is really like the first step. And then once you have a sense of what sort of risk of flooding you might want to be concerned about, the next step is to actually take some action about that. And so I hope you come back next week when we will really dive into all of those options. So as I mentioned, we are talking about coastal flooding today. And since we're focusing on coastal flooding, I want to start off by talking for just a minute about what we mean by coastal. So here at Maryland Sea Grant, we usually use this definition of coastline, or it's a tidal shoreline bordering the Chesapeake Bay, its tributaries, the coastal bays, and the Atlantic coast. So I'd just like to mention this as a reminder that we aren't just talking, when we say coast, it's not just talking about the bit of Atlantic shoreline Maryland has. It's much more extensive to that. Estimates vary depending on who's measuring and how they measure, but according to most estimates, there's over 3,000 miles of this tidal shoreline in Maryland. And as we'll discuss today, in some cases, these coastal flooding impacts can extend quite a ways inland. So it's not just specific to properties or people living just along the shoreline. So I actually have a quick question, two quick questions I would like all of you to answer, just so we can get to know each other a little bit and have a sense of who all is here and what brings you here today. You should have a poll pop up on your screen. If you don't mind pausing your eating lunch for just a second to respond to them. I'd appreciate it. So the first question is just how far you live from the coast, using this definition of all that tidal shoreline bordering Chesapeake Bay, tributaries, and coastal bays. And then also a question about what brings you here today, whether that one you can select as many choices as apply to you, whether it's part of your job, you're concerned about what's happening near your home, or you are just here to learn and learn about some of the resources available related to coastal flooding. So I'll leave this up for just another about 5 seconds. And I'll go ahead and share those results. So, okay, it looks like we have one person who lives actually on the shoreline, and then several others who are further inland. And I'm not sure that's entirely a valid question. That's entirely a valid answer, especially with this kind of different definition of what coastal is. It can be a little bit tricky. And we have folks here with for a variety of reasons, including to learn more, job about flooding, and also concerned in the neighborhood. Okay, so today we'll be talking about several different causes that contribute to coastal flooding, focusing especially on tides, rainfall, storm surge, and sea level rise. And these causes can produce flooding across a range of severities and timeframes. So some of these causes will produce more like mild chronic flooding that frequently recurs in some locations, and then other causes produce really severe flooding that can be extremely damaging but doesn't happen so often. And I'd also like to point out, and I think we'll be discussing this, another theme throughout this section of the webinar, is that a lot of these causes are really interrelated, and they can combine or exacerbate the effects of each other. So the first cause of coastal flooding we'll discuss today are tides. So here in Maryland, we have 2 high tides a day. This chart is showing tide predictions from created by NOAA for Annapolis. These are predictions for the 22nd. It's actually next week. This is the water levels predicted by NOAA at a tide gauge in Annapolis over a 24-hour period. So see, there's the 2 high tide peaks during that 24-hour and also 2 low tides. And tides can contribute to something that's called often nuisance flooding or sunny day flooding or high tide flooding. It can have a lot of different names, but what this is referring to is flooding that is happening during high tides that's not because of a storm or precipitation. And so this is happening because during high tides, water levels are higher, and in some really low-lying coastal areas, that can cause some amount of flooding. Because tides are caused by the gravitational pull of the sun and the moon on the ocean water, there are more extreme tides that can happen when there's a new or a full moon, or when the moon is positioned closer to the earth, which means that there are certain times of the month or the year in which the tides are a little bit more extreme, and this sort of flooding can happen even more commonly. And I should also mention that this sort of nuisance or sunny day flooding that isn't associated with precipitation, there's some places in Maryland where wind direction can also be a really important factor. The high tide is certainly a big part of it and can make this flooding happen. But when we have these real notable flood events, it seems to be that in many places that there tends to also be some onshore wind going the right, or maybe the wrong direction, how you think about it, to push some more water onto the land. And so this picture on the left is this sort of flooding in a rural location in Dorchester County on the eastern shore. And the picture over on the right is similar sort of flooding, but in the Baltimore Harbor area. So this is something that happens lots of places throughout Maryland. It's typically relatively mild or moderate flooding, like we're talking about usually a few inches of water, like you can see in the pictures, but it can still occur really frequently in some locations, and it can impede transportation on the roads and also cause damage to the roads and other infrastructure. So even if it does just seem like a few inches of water, it can have some real impacts. Like there's some places in Dorchester County where school buses regularly have trouble going through their route and picking up school children because there is such frequent flooding of this nature. So in addition, besides tides, another source of flooding is the rain. And this obviously isn't just unique to coastal areas. We always like to say that if it can rain, it can flood. So this sort of flooding can happen anywhere. It's not unique to coastal areas, but coastal areas can be especially susceptible to this sort of flooding if the water table is higher and the water that comes down as rain has nowhere to go, or if the ocean is impeding or storm drain management systems. So when we talk about storm drain, stormwater management and storm drains, under normal conditions, storm drains work by gravity carrying the rainwater out to the ocean or another body of water. But if the ocean level is too high, the storm drain can actually become blocked and it won't be able to function, which can cause flooding. So basically it rains, but because the storm drain is blocked by other water, the rain has nowhere to go, causing flooding. And so one example of this, if you've ever been around the Annapolis city dock sometime when it was raining and happened to be high tide, you probably encountered some water on the parking areas circled there in yellow. And I mean, this part of Annapolis has really struggles with a lot of flooding challenges, but in particular, if there's rain falling and it's high tide, that rainwater just has nowhere to go and ends up collecting in these parking lots, which can range from the kind of like mild inconvenience of like puddles you have to drive through to sometimes the whole parking lot has to be closed. And so flooding from rain can be relatively minor and frequently occurring, but there are cases, unfortunately, where it is quite severe. So this is something that occurred pretty recently, a few weeks ago in the Northeast with the remnants of Hurricane Ida. That in particular, coastal storms, so things like hurricanes and tropical storms, can produce really tremendous amounts of rain that can cause flooding both inland and on the coast. And one thing that happens sometimes is that when there is a lot of rain falling inland, that water is then transported through in streams towards the coast, which can sometimes then cause flooding issues closer to the coast. So in addition to flooding from rain, hurricanes and other coastal storms can also cause flooding through something called storm surge, which is when water is actually pushed onto the land by the cyclonic winds of a coastal storm. So if you think about the images you see sometimes of hurricanes where there's that spiral pattern. So that's called like a cyclone. So those winds that are causing that cyclone to form can also push water onto the land. And this is what can cause some of the greatest threats to life and property during a hurricane. And fortunately, this is something that doesn't happen frequently for us here in Maryland, although there have been some cases where this has happened. If anyone remembers back in 2003, Hurricane Isabel, the impacts of its storm surge were seen many places in Maryland. The storm surge was measured to be about 8 feet of water in Hooper's Island and over on the eastern shore, and about 6.5 feet over in Ocean City. So this storm surges don't happen frequently, but they're important to keep in mind because they can have such dramatic or devastating effects. And one thing I always like to point to remind folks about with storm surge is that when we talk about hurricanes and you hear about them in the news, it's almost always all about what category the storm is. It's category 1, 2, 3, 4, what have you. And those numbers are based on the wind speed of the storm, which is a factor that can help determine how much storm surge comes, how much the storm surge produced is, but it's not the only factor. So just keep in mind that when you hear about a storm coming, a hurricane, or a tropical storm, that the category can provide some information that higher category storms with higher speed winds often produce greater storm surges, but it can also depend on things like how big the storm is, how fast it's moving, storms that are the angle of approach. So if it's going onto the shore perpendicularly, that can cause more storm surge than if it's coming at more at a different angle. Also, some of the characteristics of the shoreline, of what it's shaped like, and the slope of the ocean bottom can also contribute to how much storm surge is actually seen. And as I mentioned, some of these causes of coastal flooding can really are interrelated and can compound with each other. One example of that is storm surge combined with high tide. So when this is something that a storm is moving through an area, the storm surge can be producing this potentially really devastating flooding impacts. But if it happens to come during high tide, that can cause the water level to be even higher. So you can have a storm surge plus high tide together causing even more flooding than you would see if the storm had happened to come during a low tide interval. Excuse me. So I just had a couple questions I wanted to pause and ask all of you if anyone is comfortable answering. I'm curious if anyone's experienced any of these sorts of flooding in the past, and if you have any thoughts on how this flooding might change in the future. If you are comfortable answering, this is something you can use the chat for, or if you'd rather raise your hand, I can unmute you. I can say that from my experience, I live in the Annapolis area, and I'm fortunate that where my house is, I haven't seen flooding issues yet, although I've only lived there since April. But I have had that experience of trying to park down near the city dock and not being able to because of flooding, or being over near Blackwater in Dorchester County, and had seen trying to avoid some roads that have water on them. So I'm just curious if this is something that, if anyone else has experienced any of those sorts of flooding or other ones, and then if you have any ideas on how it might change in the future. It's okay. I think everyone's eating lunch, which is quite all right. We'll keep moving on then. And just as a reminder, if any questions do come up while we're talking today, go ahead and pop those in the Q&A and I'll get to them at the next point where I look this. Let's see. Yeah, okay, we have a couple of people sharing some of their experiences in the chat that's seen some flooding events outside Cambridge. Yes, and yeah, expecting a lot more. Oh, wow, yeah, and one person had the experience of having riverfront property in 2003, which is, yeah, that was before, I was not in the Maryland region yet, but I know many of you probably were. And yes, concerned about this flooding getting worse in the future. So thinking about what's happening in the future, if you were with us last week, we talked a little bit about how climate change is expected to cause more intense precipitation events that can lead to more flooding and also more intense coastal storms like hurricanes. But in addition to that, another big factor contributing to coastal flooding is sea level rise. And this is something that we've already seen produce more frequent high tide or sunny day flooding. And it's going to continue to, that pattern is going to continue to be seen in the future. So this graph on this slide is showing water levels measured by a NOAA tide gauge at Annapolis. So it's been measuring the water level for several decades now, dating back to 1930. So about 90 years, a little bit more than that. And you can see that there's this trend of the water level increasing, which is how we know that sea levels are actually rising. And so this is happening for a few different reasons. The biggest two reasons that are affecting sea level rise all across the planet are the melting of land ice and the thermal expansion of seawater. So the melting of land ice, that's happening because as the Earth gets warmer, more glaciers and ice that's being stored on land, so things like the ice sheets in Greenland and Antarctica, those are melting into the ocean, which is making there be more ocean water, which takes up more space and makes the sea level a little bit higher. And then the other global climate related factors is expansion of seawater. And that's happening because as the Earth gets warmer, the ocean absorbs a lot of that heat, and warmer water takes up a little bit more space than colder water. So as the Earth gets warmer, heat's absorbed, and then the ocean water uses up more space, which again makes the sea level a little bit higher. So in addition to those global worldwide factors, here in Maryland and the Mid-Atlantic region, we're seeing particularly high rates of sea level rise for a couple different reasons. So in addition to those global processes, we're also seeing locally high rates of sea level rise because the land here in Maryland is slowly subsiding or sinking gradually. And that's happening for a couple of reasons. One has to do with what was happening during the last ice age. when there were glaciers that extended down through New England, but didn't get quite to Maryland. And so those ice sheets were so giant and heavy, they actually pushed down on the continent and depress the land a little bit. And the bit of the continent outside the ice sheet actually gets pushed up in response to that. It's kind of like if you stick your hand into a memory foam mattress, the foam sinks down under your hand, but then around it, it bulges up a little bit. And that bulging up area is where present day Maryland it was. So now that those glaciers have melted, the land beneath them is now rebounding, or it's returning to where it was before that ice sheet. And similarly, the area of the continent where Maryland is today is now slowly sinking or subsiding back to its original elevation before the ice sheet. And so that whole process is called glacial isostatic adjustment. And that's a big contributor of why we see higher amounts of sea level rise in the mid-Atlantic than other places in the world. And then one other factor that is contributing a bit to our local amounts of sea level rise is that there seems to be some land subsidence from groundwater withdrawal. And so this is something that's still being studied. It appears to be a bit more localized, that there are certain places in the mid-Atlantic where this is a bigger contributor, but basically as water is pulled out of aquifers, it can cause some of the land to compress a little bit, which can, and that sinking or subsiding of the land surface can make the relative level of the ocean water increase also. So when we're thinking about the causes of sea level rise, we have these two big global causes, and then we have a couple local causes that are also contributing. So I always like to point out that these are all parts of why we're seeing the amount of sea level rise we are, but those climate-related global causes are producing much more of the sea level rise that we're seeing. It's about 3 millimeters per year from those versus about 1 millimeter or so from the local causes. And these might seem like really small amounts. You're talking about like, what, about 4 millimeters or so per year, and which is tiny, but it can really add up over the years. So if you think about, that's what happens in 1 year, but then over the course of like a decade or 5 decades, that this can really start to have some real impacts on how much flooding we're seeing. And so looking towards the future, there are projections of what sea level rise is going to look like in Maryland in the future. There's actually a report produced by the University of Maryland Center for Environmental Science every 5 years, which develops projections just for the state of Maryland. And based on that most recent report, we are expecting to see in the next 30 years, by like 2050, an increase in sea level of about 0.8 to 1.6 feet. And then looking further out towards the end of the century, more in the range of maybe like 2 to 3 or 2 to 4 feet. And so one thing to mention when we're thinking about future sea level rise is that in the next 3 decades or so, until about 2050, the sea level rise, we pretty much, it's going to happen because of the climate change impacts that have already, the climate change that has already happened. But looking out further in the future beyond 2050, how much sea level continues to rise is going to be really determined by what happens with our global carbon emissions. And so if we, as we talked about last week with our growing emissions, if carbon is continued to be put into the atmosphere at the current rate, we're expecting to see much greater amounts of sea level rise than if those are limited, if those are stabilized in the next few decades. So just to circle back onto how this relates to the coastal flooding that we've been talking about, sea level rise has a really direct effect on the high tide or sunny day flooding that we're seeing. And so this is a chart showing high tide flooding in Annapolis, Maryland. You'll see that there in the recent decades, in the last 10, 15 years or so, there have been more cases of high tide flooding. And that increase is happening because of sea level rise that's already happened. And then looking towards the future, this flooding is expected to become even more frequent in the coming decades. And these two color bands are showing the amount of flooding that's expected to happen under that lower emission scenario and that higher emissions scenario. And you can see that even by in 30 or so years, by 2050, there could be potentially 75 to about 200 or so in days each year of high tide flooding, which is just really, really quite dramatic. And in addition to that, I just also wanted to note that these higher sea levels can also contribute to flooding from the other sources we talked about as well. So when the rainfall flooding, we're talking about how the ocean water can block storm drains and impede stormwater management and cause flooding. Higher sea levels can make that occur more often. And also higher water levels can produce, higher water levels mean that there can be more water there that can then get pushed onto the shore in the form of a storm surge. So that can also be exacerbated by sea level rise as well. So I just want to pause and see if there are any questions. I don't see any at the moment. I'll give it just a second. There'll be an opportunity at the end. I can answer any questions if anything else comes up as well. So what I'd like to talk about now are some of the mapping tools that are available for understanding this flood risk. So we've talked about a lot of the different causes of coastal flooding, but now the question is so what does that actually mean for me or my home or my community? And so I'm going to share a few of the tools that are out there for trying to understand what your flood risk is. And I'll be talking about a few different tools. And the reason for that is because there isn't really one perfect tool for all situations. So for each one, I'll talk a little bit about what it does and what it's good for, and then also what its limitations are. And just as another reminder, as I mentioned at the beginning of the webinar, this is really the first step in understanding your risk. And so after that, so next week we'll be talking about things you can do to help reduce it. So the first tool I wanted to share with you are flood insurance rate maps. And so I'm going to put a link to this in the chat in case you would like to check it out for yourself now or in the future. So flood insurance rate maps. These are created by FEMA, the Federal Emergency Management Agency, and their real purpose, or one of their major purposes, is that they are what's used to determine if flood insurance is going to be required by your mortgage lender when you buy a house. So there are certain areas that FEMA has identified as being susceptible to flooding, and those are places where communities are expected to do more floodplain management and controlled development, and there's more regulations on what can be done in those areas. So these maps produced by FEMA, they show areas that have a 1% annual chance of flooding and a 0.2 annual chance of flooding. So this is sometimes it sometimes is referred to as a 100-year flood or a 500-year floodplain. We're trying to shift to talking about the annual chance of flooding, because it's important to remember that when you hear 100-year flood, it sounds like if it happens once, then we should be good for 99 years without worrying about that sort of flood happening again. That's really not how it works. It's like every single year, there's that 1% chance of annual flooding. And so these maps are available for everywhere in Maryland, not just coastal areas. If you've bought a house recently or anytime in the last, actually many decades, somewhere in that giant like 6-inch stack of papers that you had to go through and sign, it would have said whether you are in one of these flood zone areas that requires flood insurance. And yeah, just one other point about that 1% annual chance of flooding, that doesn't always sound like a lot, like, oh, there's just a 1% chance there's going to be flooding this year. But if you think about that over a 30-year mortgage, there's actually about a 1 in 4 chance that there will be flooding sometime during that time period. And so a couple big caveats with these maps and using them to evaluate your flood risk are that they do not consider future conditions at all. They're based entirely on flooding that has happened in the past. So it's not taking into account the fact that we're expecting to see more precipitation in the future, that coastal storms might be more intense, that the sea level is rising. It is just based on past flooding. So it can still be a useful tool and provide some information that if you are in one of their designated zones, that could mean that there is a relatively high risk of flooding. But keep in mind that more and more what's happened in the past isn't necessarily a good indication of what will happen in the future. And another point is that just because you're outside of one of these designated flood zones doesn't mean you won't flood. And so the National Flood Insurance Program, about 20% of the claims made through them are from areas outside of those high-risk flood areas. So the point there is just to keep in mind that if you are in one of the FEMA designated zones, that's an indicator that you might want to be thinking more about flooding and what you can do about it. But even if you aren't, there is still a certain likelihood that you could still encounter flooding. So what I'd like to do now is just real quick, I'm going to go over to this is what the website linked there looks like. This is the mdfloodmaps.net website, just to show you what it looks like. it can sometimes be a little bit slow. So I'm hoping it seems to be working all right today. So you can either enter an address into the address bar in the top left corner, or you can just zoom into an area of interest. So I'm just going to zoom in here to, this is around Ocean City. And so this is just an example of what the maps here can look like. If you click on the symbol with the 3 lines, it'll show you the legend. But essentially, these areas in blue are showing the places where there's that 1% annual chance of flooding. And the orange areas, that's the 500-year floodplain, or that 0.2% chance of annual flooding. And so you'll notice that these also have, there are also different letters on some of these blue areas. So within the designation of being a high risk flood area that has at least that 1% chance of annual flooding every year, there's a few different sorts of zones that FEMA designates. All those areas that said AE, though, that means that there's that 1% chance of flooding each year. We also might have seen that there were some that said VE, which means that they have that same 1% chance, but they're also in a location that means that there's some additional risk of flooding from waves on top of that flooding. So if you can think back to, you can actually just pull it up. When we're looking at Ocean City, you'll see the ocean side ones are all the VE zones, whereas the bay side are AE. So that's when you're looking at these, they're both within that 1% annual chance, but the VE ones have the added potential damage from waves if there was a flood of that nature. So another tool I'd like to share is something called the NOAA Coastal Flood Exposure Mapper. And I'll put that in the chat as well. So this is something created by NOAA as a way to visualize several different hazards. So it shows some flooding impacts from storm surge, high tide flooding, sea level rise, even tsunamis. So one of the strengths of this mapping tool is that it includes so many different hazards, but the one limitation of it is that it's really designed for more of like a community level risk assessment. You aren't able to zoom in as close as we were able to with the flood map tool we were just looking at. It's really designed more for seeing, where in a neighborhood is flooding potentially likely than looking at like one particular property or parcel. So I'm going to go pull that up real quick. So here on the coastal, this is what the Coastal Flood Explorer Mapper, it's kind of opening page looks like. And if we say get started, you'll notice that this is something that is available for all coastal areas in the US, at least the contiguous 48. I can't recall right now whether Alaska and Hawaii are included or not, but this is something that our neighbors in other states can use as well. And so once again, you can either search by a specific address in the address bar or zoom in on a certain area. So I'm going to zoom in here. I'm going to go to Solomon's Island, where the University of Maryland Center for Environmental Sciences has a station out there on Solomon's Island. And so if we click the legend, or sorry, this symbol over here, the little stacked up layer selector icon, that pulls up an option where we can see all the different hazard layers that we can look at on this map. and either select or deselect them. So the default is this coastal flood hazard composite, but I'm going to turn that off for a minute so we can look at some of the other choices here as well. So notice that one hazard layer is called high tide flooding. So if you select that, certain parts of the low-lying areas near the coast are shaded in on red. And so those are places that are prone to flooding during extreme high tides. One caveat or potential limitation of this is that it is based on national thresholds determined by NOAA. It's not locally specific. So just keep that in mind, that where it's showing red, there isn't necessarily always going to be flooding during high tides, but it's a general indicator that those are places where that might be a concern. Another hazard layer you can turn on are the FEMA flood zones, which we were just looking at on that other tool. I think they're a little bit easier to look at and use on that Maryland specific mapping tool we were just looking at, but this is another option if you prefer more of like the one-stop shopping. You just aren't able to zoom in as far or get as much information about an individual property. And then this feature also has a storm surge option, and that you can actually adjust to look at different categories of hurricanes. You'll remember I just said recently that the category of a hurricane isn't necessarily an exact predictor of how much storm surge, but it is a contributing factor. So, and it's kind of these are general estimates based on storms of these different categories. And so that's something that you can adjust to see different amounts to see how much flooding might happen based on these different categories of storms. And if you click over on the legend, you can see these different colors correspond to different amounts of flooding during that storm. And finally, the last feature on here I wanted to share is that it can show different amounts of sea level rise. So right now, this is just showing water levels at a mean higher high water, which is where the water level is during the normal highest high tide of a month. But you can then adjust this slider to show where the water level would be with, this is showing 1 additional foot of sea level rise on top of that normal highest high tide. Can also increase it to see 2 feet, which is, if you'll recall, that's about what we might expect to see around like 2050 or so, and then continue to increase it to see what areas might be flooded several times a month during high tides at around 2100 or so. And so these light blue areas on the map are showing what could be impacted by sea level rise in the future. So all these different hazard layers and can be really helpful for thinking about flood risk from a number of different factors. So this can also help you think about the potential storm surge that is maybe, because it happens so infrequently, it's not really captured in those FEMA maps, but it's still something to potentially consider. And then also looking towards the future, thinking about that sea level rise. So I'm going to go back to the presentation for just a minute. So those are two, we talked about 2 tools that can provide a good amount of information about understanding your flood risk. But there's this real kind of outstanding question of how sea level rise and storms are going to combine to affect flooding in the future. You'll think about that, the flood exposure mapper we were just looking at. It's like we could look at either a storm, a category 2 storm or whatever, or sea level rise. But the fact of the matter is that thinking towards the future, we're going to have sea level rise, but we're not going to stop having storms. We're going to keep having storms also on top of that sea level rise. And those storms might even are likely going to be worse than we're seeing today because of the other effects of climate change. And so, unfortunately, this is something that today there is not one really great mapping tool available yet that can really show how these different factors are likely to contribute to coastal flooding in the future. This is something it's an active area of research of trying to model this and think about how to visualize it, but we're not quite there yet. So I don't have a fantastic tool to share with you. One kind of baby step in that direction is this one other tool. It's called the CoastSmart Climate Ready Action Boundary. This was developed in response to the state of Maryland's CoastSmart regulations, which oversee how, so if state money is being spent on projects near the coast, they're expected to meet certain standards if they're in areas at risk of flooding. And so this mapping product was developed to address some of the requirements in those regulations. And so that what these recently produced maps show is the FEMA flood zones, those areas with that 1% annual chance of flooding, plus an additional 3 feet of water. So this can show, this is starting to go in the direction of thinking about, okay, so we have a 1% annual chance storm that we want to plan for, but we know storms are going to be bigger and sea level rise is going to happen. So adding those additional 3 feet can help identify larger areas that could be at risk of flooding in the future. That said, it's not very specific or adjustable yet. You can't change the 3 feet of water more or less. And also, this is based on today's 1% annual chance flood. And there's been some recent research saying that, you know, what is a 1 in 100 chance storm today is going to be more of a 1 in 10 or 1 in 20 chance flood in storm in 2050. So this isn't entirely addressing it, but it's one potential tool to kind of move in the direction of thinking about how these different factors can combine and what that means for risk in different areas. So we are coming up to almost 1 o'clock. I hope that these tools were useful for you in thinking about flood risk, both like what's happening now and what it might be like in the future. I am more than happy to answer any questions, whether they're kind of general questions about the tools or specific questions about your situation. This is my contact information. If you would like to follow up with any questions in the future, I am more than willing to set up a time to talk more specifically about individual flood risk concerns. But in the meantime, if you do have any questions, you can go ahead and put those in the Q&A or raise your hand and I can unmute you. As another reminder, next week we have one more session in our Coastal Flooding and Climate Change webinar series. That will be same time, same place next week. Okay, I shouldn't say same place. You do actually have to register separately for each webinar. It's a little bit annoying, I apologize, but you can do that at the website listed there, and we'll be talking about some of the different things you can do to actually address these flooding problems, both at the individual like, property level, things you can do to make your house more resistant to flooding, and then also how to make a neighborhood or community more resilient as well. So I will stick around here to see if there are any questions, but in the meantime, thank you all very much for coming today. I appreciate you taking the time out of your lunch break, and I hope to see you next week as well. Thanks, everyone. Have a good Thursday afternoon.